When I was a coach for wrestling, baseball, softball, I even did a little bit of soccer. A very big influence on me was a man named Tommy Grimm. And Tommy taught me that the more you make the game like practice, and the more you make practice like the game, the more successful that you are going to be. Now, I had a lot of very successful teams, but they were really successful because of the kids on the team and because of the people that were put in my life that taught me how to do what I was supposed to do. And that whole idea of the more you make practice like the game, and the more you make the game like practice, the more successful you'll be. That requires that when you become a teacher, you scout out what your opposition is going to be. And I don't just mean if you're a coach. I mean if you're a teacher. What are end-of-year tests going to be like? What responsibilities do your students have? And make sure that you spiral through and you spend a lot of time prepping them for what they're going to be expected to perform at, or what will be expected of them. One of the greatest compliments that I receive, and I used to get it all the time, I would tell my students that every night when I gave homework, the homework was cumulative, and it was supposed to look like a mini Regents exam with a little bit extra emphasis on recent material. And I said, I'm doing a great job as your teacher and the Regents is a big statewide exam they give in New York. I'm doing a great job as a teacher if when you take your Regents exam, you look at me and you say, hey, you know what? That was just like one of our normal homeworks. I wasn't stressed at all. And that's exactly what I'm trying to do with this praxis. There are certain topics that are guaranteed to be on the test, so I want to make sure we go over those and show you all the little variations off of them so you don't miss them. And then I want to show you ways to become test savvy, like we just worked on with checking the solutions. In case you have no idea how to solve the equation, you can always check the solution and get it right and not have a clue how to do the math behind getting the answer, but you get credit for it, so then you will succeed. Now, likewise, the Pythagorean theorem is something that you can expect to see on your test. And this is what the Pythagorean theorem says. It says a squared plus b squared is c squared. That's the most common way of presenting it. I don't like that very much because I remember one year on the state exam, they put the c as a leg instead of the hypotenuse, and it caused, I want to say 95% of the kids in the state to miss the question. And this isn't to try to make me look great. That's not it, because there were other areas where my students would struggle and I had to go back and adjust how I taught things, but this was not one of them. I always taught it leg squared plus leg squared is hypotenuse squared, and the students knew that the legs make up the right angle, and most importantly, the hypotenuse is across from the right angle. I actually used to ask them to draw a line from the right angle to the opposite side to highlight what the hypotenuse was. And then when you do that, it doesn't matter where you put the c. In fact, you could use the x, y, and z. It makes absolutely no difference. So I like leg squared plus leg squared is hypotenuse squared. You use whatever you're comfortable with using. So here's our question. Find the value of n. Go ahead. Remember your stop and start. Okay, so beginning with what I'm real comfortable with, which is leg squared plus leg squared is hypotenuse squared. The legs are 6 and n. Some of the common misunderstandings, some students will say, oh, I understand that Pythagorean theorem. It's just number squared plus number squared is letter squared. No, absolutely not. It's leg squared plus leg squared is hypotenuse squared. So the first leg, remember the legs make up the right angle. So the legs are 6 and n, and the hypotenuse is directly across from the right angle. So if you want, draw a little arrow directly across to the 10. So what I get is that 6 squared plus n squared is 10 squared. 6 squared is 36 plus n squared, 10 squared is 100. Subtracting 36 from both sides, n squared is 64. Square rooting both sides, and I get n is the square root of 64, which is better known as 8. So the value of n is 8. Now, one of the great things about taking a video online course is if necessary, you can go back and look over anything that I present to you again, rewind, and just watch it again, okay? If you had any trouble, rewatch before you hit this one. Go ahead. Stop and start. Okay, so it's a right triangle, so I know it's leg squared plus leg squared is hypotenuse squared. The legs make up my right angle, so the legs are 5 and 12. The hypotenuse is across from the right angle, which is n. So this one's a little different, you see. The 5 and the 12 are on the same side this time. So 5 squared is 25, 12 squared is 144. Oh, that shouldn't be the squared there. I always make stupid mistakes, I'm sorry. Equals n squared. 169 is n squared. Square root both sides. N is 13. So this time you do add them together. So there is no rule that says you always add them together, you always subtract them. It doesn't exist. If you want to get it right, write leg squared plus leg squared is hypotenuse squared, and put all of the beginning numbers where they belong, and then just follow the steps. Then you will get it right. So, and just so you know, this is not the only time you're going to see the Pythagorean theorem. You're also going to see the first type of question that we did where you check solutions again in the upcoming class. So we spiral these things through. We don't want you to lose track of these test-taking strategies. Often, the difference between success and failure, Bill Parcells used to say about football that who wins the game comes down to about 5, 6, 7 plays a game. Who wins those 5, 6, or 7 plays? And passing the praxis test, there's a bunch of questions on that test you're going to get right. And there are probably some questions on that test that many of you will struggle with. The question is the ones in between. Who's going to get the most of those right? And that's what these strategies are designed to address. Okay, find the area of this particular rectangle. Go ahead. Remember to do your stop and start. Okay, so the correct answer is 24 square feet. Now, where's that coming from? Well, to understand area is what's inside of a rectangle. And if this is 6 feet long, then I make a mark every foot, 6 total marks. That's across the length of the figure. For the width of the figure, if it's 4 feet long, I make 4 marks across, okay? Now, how big or how many of these 1 by 1 marks do you get inside the rectangle? Well, what you find inside the rectangle is 24 such marks. I have a column of 6, a column of 6, a column of 6, a column of 6, and so on. That's 4 rows. I should have said a row of 6, sorry. That's 4 rows of 6. 4 times 6 is 24, okay? Area is about covering. It's all about what's inside of a figure. To figure out the inside, you have to multiply. You add to get to the outside, and the outside is called perimeter. Okay, so area is on the inside. And you'll notice these choices. If you take a look, they have half the perimeter is 10 square feet. The whole perimeter is 20 square feet. So they're trying to mess you up based on the idea. So just remember, area is what's on the inside. And if you chop it up into 6 pieces by 4 pieces and you multiply 6 by 4 is 28. Okay, so here are some area formulas, some basic ones that you should know. What I might suggest is as I get through all of these, just take a picture at the end. Area is going to be length times width for a rectangle. For a parallelogram, it's base times height, and there's a picture of a rectangle and a picture of a parallelogram. For a triangle, it's actually half the base times height. And notice how we show this. We start with a parallelogram, but a triangle divides it in half. So there's 2 triangles in a parallelogram, which is why the area of a triangle is half the base times the height. And finally, the area of a circle is pi r squared. How do you remember that? Just remember apple pies are 2. Later on, when we talk about circumference, we'll add in cherry pie is delicious. But the 2 of them put together are cherry pie is delicious, apple pies are 2, area apple pies are 2. Okay, and sometimes you will, no, this is a good point, which to take a picture, by the way. At some point, you might be asked to find the area of a figure that combines more than one area, and sometimes you have to find a missing piece. Okay, so if you look here, this trapezoid is made up, and I'm not going to get into a trapezoid formula. Area formula. I would rather understand how you figure out the area. Area is always what's on the inside. So what do I have on the inside? What I have on the inside is a rectangle, and I can find the area of that rectangle, right? That's pretty easy. You got a 6 meters and 3 meters there. And then I got to find the area of that triangle on the end. But we remember that the formula for the area of a triangle is a half the base times the height. So let's start picking through what I do know here. I know the area of a rectangle is 6 meters times 3 meters. Why does that say 8 meters? Okay. Quick correction here, guys. First time that I'm going to do this. I will make mistakes during the year. I apologize ahead of time in advance for it. And we will hopefully get as few of these as possible, but I'm not going to go back and redo the video that I've done on this so far. Okay, so the area of the rectangle in the middle is 6 meters times 3 meters, which is 18 square meters. Okay. And that covers the blue. But if you notice, I didn't get to these triangles on the end. So how do I do the triangles? Well, I know the height of the triangle is 3, but I don't know this base piece. I know the hypotenuse is 5. Well, this is a right triangle, so we can go with the Pythagorean theorem, which means leg squared plus leg squared is hypotenuse squared. So 3 squared, that one leg, plus the other leg is n squared, is going to equal 5 squared. 3 squared is 9, 5 squared is 25. Subtract 9 from both sides. N squared is 16, so n is 4. Square root of 16, which is, of course, 4. So that allows me to put a 4 in on that side. And now, for the area of the triangle, I'm going to get half the base times the height. So that would be half of 3 times 4. And half of 3 times 4 is better known as 6. So what's the area of the whole figure? It's the rectangle in the middle that we said was 18. And then I've got a 6 on the right-hand side and a 6 on the left-hand side for each triangle. So 18, 6, and 6 is 30 square meters. Okay? So that's a way to digest area. Which, if you get one of these odd-shaped figures like a trapezoid, you could know the formula. I'm not sure if they give you a formula sheet, but sometimes they even give you irregular figures for which there are no formulas. So you just understand, area means what's on the inside, and then you go about the process of figuring out what that area is. Okay? And the last thing we want to talk about is when it's important to draw a diagram. A woman wants to park her 15-foot long car in a garage that's 19 feet long. It's kind of funny. We have a garage on our house, and I have an old Willys Jeep, a 1955 Willys, and between the pallets for the wood pellet stove and the Willys, and then when I tried to get my Ram 2500 truck into the garage, by about 6 inches it didn't fit. So that and a handful of other reasons, we wound up building a separate garage on the outside of the house so I could fit my truck in it. So fitting your vehicle in the garage can be something that becomes a real problem in this world. Okay? So the woman wants to park her 15-foot long car in a garage that's 19 feet long. How far from the front of the garage will her front wheels need to be so that the car is centered on the floor of the garage? So you got to draw a diagram to get this right. And sometimes that's a great strategy. In fact, it's a great strategy pretty much all the time. So I'm going to draw the garage. And the garage has a 19-foot long section there. And then I'm going to put the car in the middle of the garage. Try to make it spaced evenly, okay? Now, here's the problem with this. Who knows where the wheels really are? I mean, most cars, the wheels would be about here. But for these purposes, I think they're assuming the wheels are at the end of the car, all right? So go with that as best you can. I just think it's a little bit of a faulty question. And if they gave me one like this on the PRAXIS, I would be upset. But we'll go with it, and we'll assume that the vehicles are at the very front of the car, or the wheels are at the very front of the car. So if the whole thing's 19 feet long, and the vehicle is 15 feet long, that means 19 minus 15 is 4, and we want this centered on the floor of the garage, which means these two distances here at either end of the car have to be equal. 19 minus 15, like we said, is 4, so that's 2 feet for each of those parts. And there's my answer of 2 feet. Okay, so we've now reviewed all of the PRAXIS question types that I want to get into for today. This is for test-taking strategy, savvy. What did we go over? We went over the Pythagorean theorem, okay? I'm sure that'll be part of a little lesson later on in the course, but that's going to be on the PRAXIS test. It's on like every test from 8th grade on up in the United States of America. We went over the idea of if they give you an equation and you don't know how to solve the equation, just check the answers, right? Just plug them in, see which ones check. You should never get that question wrong in a million years, even if you have no idea how to do the equation, because everybody knows how to check. We talked about the need sometimes to draw a diagram because it really helps you see things better. And we talked about how area is what is inside of a figure, and we mentioned that perimeter is the outside. We didn't dwell on it. We'll talk about perimeter, I'm sure, at other points during the course. But area is what's inside the figure. So that is our review of the praxis situation for today. And because there was a little bit of teaching involved, it took a little longer than normal. Normally, it won't take that long at all. Next thing we would normally go over in class is the review questions. However, today is the very first lesson of the year, so there really are no review questions to go over. So we will stop this video now, and then we'll start with our classroom contemplations, the new stuff, in just a minute.